Bismillahirrahmanirrahim. Welcome to the lecture on cloud computing. So this is the definition for the cloud computing according to the NIST. A model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Example networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So, what is ubiquitous? So, if you check the synonymous, you can say it's a global, okay, universal, a model for enabling a global and convenient, easy to use, on demand network. So, when the customer or when the client requests some services from the cloud service provider, based on the request, based on the demand from the customer, the service would be provided or provisioned. So through the cloud computing, we can access a pool of resources, shared pool of resources. So there are a lot of set of resources already available, which can be instantly configured and provided to the customers. So what are the resources? Example, servers. So if the customer wants a server operating system, uh, the customer can avail the service through the cloud computing. Or the customer wants storage facility service, then he can avail that service through the cloud computing. Or the client wants to access applications, that also can be made available by the cloud service provider to the customers. Example, Gmail, etc., OneDrive, Google Drive, etc., and so on. Many services can be provided to the cloud customers. These services can be rapidly provisioned. So when the customer demands some kind of service from the cloud service provider, it can be quickly provided to the customers. That's what referred here as rapidly provisioned. Quickly, it can be provided and released. It can be provided or it can be released with minimal management effort. All most of the things are automated. So when you want to you want a storage facility for your files or folders, then you can we can go for OneDrive or many such Google Drive. These are automated services. It can be the customer can avail the service through the applications with minimum effort and also with minimum interaction with the service provider. So the cloud model promotes availability and is composed of 5 essential characteristics and 3 service models and 4 deployment models. Let us see what are the essential characteristics, what are the service models and deployment models in this figure. So this figure depicts cloud computing elements. These are the essential characteristics. So the first essential characteristic is broad network access. So broad network access means the clients can access the services through various devices. So what is broad network access means? Essential characteristics of core computing to cover is broad network access. Okay, so it capabilities are available over the network and access through standard mechanism that promotes use by heterogeneous thin or thick client platform. Example: mobile phones, tablets, laptops, and workstations. So the cloud characteristic of broad network access means that the service can be accessed from multiple locations using multiple different type of clients. So this is exact. It gives the clear explanation about what is this characteristic refers to broad network access. That means the service can be accessed from different locations, multiple locations. Okay, from the home or from the branch office or from the corporate office, and also using different devices, thick and thin clients, PC, okay, laptop, desktop. So this feature, this characteristic which is available with cloud computing is called as broad network access. The next one, next characteristic is what we call it as elasticity. So based on the client request, the services, the resources are provided. So the resources increases and decreases based on the demand of the customer. So these processes are automated. Automatically, the size of the resources, the number of resources available scales up, scales down, and it increases, decreases automatically according to the demand of the customers. So the cloud elasticity means the elasticity refers to the ability of a cloud to automatically expand or compress the infrastructural resources on a sudden up and down in the requirement so that the workload can be efficiently. Okay, so this is the exact meaning of this elasticity. Okay, so the physics property elasticity means it is expandable and then it can contract. You can take a rubber band. Okay, when you pull, it would expand. Then when you are not pulling, then it would contract. Okay, so this is a property which the cloud computing also possesses. Then measured service. So what is measured service means? The services provided to the customers are metered, or we can say measured. Example, let's say the customer wants to have a cloud storage. So, like how it can be measured, how much GB storage capacity the customer has consumed. For example, let's say for 50 GB one amount of package. Okay, so 50 to 100 GB another amount of another type of package. So these packages differs applicable to the customers based on how much storage the customer has consumed. So this we can call it as measured service. Okay. So this is also another characteristic of cloud computing. On demand self-service. So as far as the cloud computing is concerned, Everything is automated. The interaction between the customer and the cloud service provider is automated. So when the customer wants to buy some storage or he wants to use, there are different types of service which we will be discussing shortly. So these services, there is less interaction, physical interaction, manual interaction between the customer and the service provider. Mostly it is done as a self-service, automated. Then another characteristic is called resource pooling. So a lot of resources are available in cloud computing, which are created using virtual machine technology, and it would be existing as a readily available resources. They would be existing in a pool. So when any demand occurs, whenever there is a demand from the customer, the resources from the pool would be allocated to the customer. So when the customer release the resource, okay, when the customer is no more in need of that specific resource, and if he wants to just give up the resource, then the resource would be released and added with the existing resource pool. That would be added to the resource pool. And the next topic, what we are going to discuss is service models. The cloud service model can be classified into three categories. One is software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, IaaS. So what's this different things? Let us see. Software as a service, let's say. So what is a SaaS? Software as a service. Software as a service allows users to connect and use cloud-based applications. So that's the bottom line. So through the software as a service, the customers can uh, avail the application services from the cloud service provider. So the cloud service provider, they develop, they deploy, or they configure the applications in a central location, and which the service is ubiquitous in nature, that is global in nature. And this service can be made available to the customers, provision to the customers. These are different words which we can use in the cloud computing. Provision means can be provided to the customers over the internet. Okay, so this kind of services comes under the category SaaS, software as a service. Common examples are email, okay, so Google Mail, Outlook from Microsoft, and calendaring, and Microsoft Office Online. So these kind of services comes under the category of software as a service. So software as a service provides a complete software solution that you can purchase on a pay as you go basis from cloud service provider. You rent the use of app for your organization and your users over the internet, usually through the browser. Okay, so I don't want to go deep into this topic because just I want to say what is SaaS. The next one is called platform as a service. So what is a platform as a service, students? Now just imagine a situation. You want to develop your application, software. So to develop your software, you need a set of tools, software development frameworks, okay, like Java based or Python based. Some applications you want to develop. For that, you need APIs, application programming interface, any library files. Then also you need IDE, integrated development environment. Excuse me. Then you need software development frameworks, etc. So this software development environment can be also we can get from the cloud service provider as a service, and this service belongs to the category PaaS, platform as a service. Platform as a service is a complete development and deployment environment in the cloud with resources that enable you to deliver everything from simple cloud-based applications to sophisticated cloud-enabled enterprise applications. So through the PaaS service, what is available from the cloud service providers, the developers, software developers, they can develop any kind of applications, whether a simple application or a high-end enterprise level applications. For example, you want to develop an application for banking, e-banking, electronic commerce, or a simple application for a small store. So all these kind of application development can be facilitated by the platform as a service. You purchase the resource you need from the cloud service provider on a pay as you go basis and access them over the secure internet connection. So in the past, what you get, we get development tools, then we get the middleware. Middleware means it's a software through which heterogeneous applications they interact with each other. So DBMS systems and many such kind of development tools and technologies are available through the PaaS service. So this is what I want to tell about the PaaS. Then we have the infrastructure as a service. So you can see here at the bottom you have the infrastructure, you have the servers, you have the storage, you have the networks over operating system over which you build the okay, based on over that you have a platform as a service which provides you development tools to develop the softwares, and then you develop and you configure and you deploy. So that is the available as a software which can be made available provision to the customers as a software as a service. So you can see the servers and storage belong to infrastructure as a service. Then infrastructure, networking, firewall security, data center, physical plant building, all comes under infrastructure as a service. And here in the platform as a service, software development tools, database management, business analytics, and operating system, they come under the platform as a service. And software as a service, some hosted applications, example Gmail, Outlook, etc. So infrastructure as a service is an instant computing infrastructure provisioned and managed over the internet. It is one of the four types of cloud services along with software as a service, a platform as a service. So you can see the example of infrastructure as a service. So that's a basic foundation on which other services exist. That's all I want to tell about the different service models. Then let's move on to the next one, deployment models. What is public, private, hybrid, and community? So next topic which we are going to discuss is deployment models, public, private, and hybrid, and community. So what is a public cloud? Public clouds are the most common type of cloud computing deployment. The cloud resources like servers and storage are owned and operated by a third party cloud service provider and delivered over the internet. So in the public cloud uh, concept, the resources are owned by the third party cloud service providers such as Amazon, Microsoft, Google. So these cloud service providers, they own the resources and they provide these resources to their customers. With a public cloud, all hardware, software, and other supporting infrastructures are owned and managed by the cloud provider. Example, Microsoft Azure. Okay, Azure is from Microsoft, is an example of public cloud. So in a public cloud, you share the same hardware, storage, and network devices with other organizations or cloud tenants. So same infrastructure like hardware, storage, and networks are shared among multiple customers, users who are referred to as tenants in the public cloud, cloud computing. So the customers access the services and manage the account using a web browser. Examples of public cloud computing are email, online applications, office applications, storage and testing development environment. So Gmail, Outlook are examples of public cloud, and also applications. Example Office 365 and storage, for example, OneDrive, Google Drive. Okay, so these are the advantages of public cloud computing. Lower cost, no maintenance, um, near unlimited scalability, high reliability. The second one is called private cloud. So a private cloud consists of cloud computing resources used exclusively. These resources belong to one organization or one business entity. This is very important. So in public, public infrastructure is shared among multiple tenants, whereas here the resources belong to uh, cloud service provider. Whereas in the private cloud computing, resources exclusively belong to one organization or business unit. The cloud infrastructure can be located at organization premises on-site data center, we call it. Okay, so the data center can be situated at the organization physical premise, or sometimes the organization can buy exclusive service from a cloud service provider, but that just specifically to a organization. A private cloud, the service and infrastructure are always maintained by a private network, and the hardware and software are dedicated only for a specific organizations. So this way, the private cloud can make it easier for an organization to customize its resources to meet specific IT requirements. Private clouds are often used by government agencies, financial institutions, example banks. Okay, so the cloud service specifically customized to a organization or a business entity or to a government entity. So these are the advantages. And another one is called the category is called hybrid. It's a combination of public and private. So some customers take advantage of the hybrid cloud to achieve global scale, increased reliability. For example, an application resides on a premise in a private cloud. Okay, so some organization they have some private cloud service. Because of high demand, they are not able to withstand the demand which is coming from the customers. So they move on to, I mean, they take the service of the public cloud also. Sudden spikes in demand may overload the capacity, such as some online shopping in the or tax filing in the government. So when the demand increases, the organization can take the service also from public cloud, sometimes called the cloud bursting. So through the hybrid cloud environment, organization uh, allows on-premise infrastructure to burst through the public cloud. So organization makes use of predominantly they have private cloud, but when the demand increases, they can avail the service from the public cloud computing also. The next cloud computing model is community cloud model. This allows systems and services to be accessible by a group of organizations. So it shares the infrastructure between several organizations from a specific community. It may be managed internally by organizations or by the third party. The community cloud model is shown in the diagram. So when multiple organizations they want to collaborate with each other, they have a common interest, and they are dealing with a specific issue or specific problem. They can be they can avail this specific cloud service model, which is community. So this service model integrates multiple organizations uh, into this service model, which has a common goal. So there are multiple benefits. For examples, let's say many banks, let's say many banking institutions, let's say they have a common uh, service requirement, maybe payment gateway, payment, etc. So instead of making separate investment, private cloud service, they can collaborate with each other through the community cloud model. So bank community cloud model. would allow different banks to integrate their services for a specific business requirement. Example, payment facilities, services, etc. Okay, so this is the best example for community cloud service. So this is what I want to say about the different deployment models. Now this figure depicts cloud computing context. So we have many devices, cloud users, um, okay, uh, and let's say this is the data center, cloud service provider data center. There are a lot of virtualized resources, servers, storage devices, network infrastructure. Okay, so this is accessed by the cloud customers through the network. So now we are going to see the NIST cloud computing reference architecture. So first of all, you should know what is the NIST. Is a non-regulatory federal agency in the United States of America, Department of Commerce. The NIST's mission is to promote U.S. innovation and industrial competitiveness uh, by advancing measurements, science, standards, and technology. Okay. So they have given a cloud computing reference architecture which depicts each and every components that are involved in the cloud computing. Cloud example, cloud consumer, the entity which consumes the service provided. For example, we all use the email, Google email, OneDrive. So we are all the cloud consumers, examples of cloud consumers. And cloud service providers, example, Amazon, Azure from Microsoft, Alibaba, uh, okay, Heroku. These are the cloud service providers. And there are some another category that are involved is cloud auditor who review the various aspects of the cloud service provider service. Examples, security, privacy, performance. And um, of course, already we know that service layers, software as a service, platform as a service, infrastructure as a service, already we have discussed. Resource abstraction and control layer. Okay, so we have set of resources, resource pools that are abstracted and controlled in this layer. A lot of resources like networks, storage, servers, etc. And beneath that, you have the physical layers like hardware's, real hardware infrastructure. Okay, so memory, CPU, etc. Cloud service management has business support. Um, okay, provisioning. Provisioning means providing the service to the customers. And configurations. Most of these provisioning and configurations are automated on demand. It is provided to the customers. Portability and interoperability. It deals with like the cloud service should be made available to various devices. It should support various devices, various platforms like mobile, client, side devices like mobile, desktop, laptops, etc., thin and thick client devices. And it should support the interoperability among various technologies, hardware and software technologies. And also the cloud service provider has to configure the security, and that includes the privacy of the data. And we have cloud broker. The cloud broker is the entity between the consumer and the provider. So you can see from the meaning itself, you can understand broker. So the entity exists between the consumer and the provider. So he can exist as intermediate between the consumer and provider, and he can this entity can do the intermediation, acts as an intermediate. Service aggregation. So we all you will be learning this shortly. Aggregation means like um, many service providers are available. So this broker takes all the service from different service providers and uh, combine them, and this is called service aggregation. So combines them specific services and provide to the customers in a different way. And also there is a service arbitrage, which I shall explain in the coming slides. So cloud providers can provide one or more of the cloud service to meet IT and business requirements cloud consumers to the cloud consumers. So Amazon, Azure, okay, and then Roku, Alibaba, they can provide many different types of services based on the business requirements. For each of these services, like which can be categorized into SaaS, PaaS, or IaaS, the cloud service providers uh, provides the storage and processing facilities. So basically, uh, these cloud service providers, when they provide whether it's a SaaS or PaaS or infrastructure as a service, the basic fundamental thing what they provide is processing that takes place in their premise, in their environment, and also storage, and also they provide this interface through which the customer and the cloud service providers can interact with each other. So this is the interface. So we can create an account, we can sign in, then just we can avail the services provided by this service provider. So this is the interface. So when we obtain some service from this service provider, the processing takes place at the premise of the service provider, and also if there is any storage involved, the data are stored at the site of the service provider. For software as a service, students, already we know that through this service, software as a service, the service provider provides some applications. Okay, they develop the application, they test, then they configure and they deploy the application at their data center, and they make this visible to the customers, so the customers can avail this applications. They can use these applications. So this is how they do the software as a service. And platform as a service, already you know that already we have explained. I have explained. They provide the software development environment, APIs, frameworks, then engine, compilers, interpreters, engines, and database. Okay, so runtime software execution stack, that is the compilers and interpreters. And components means like methods, library methods, APIs. So they provide using which the customer, who is the developer, software developer, can develop a software. So when you want to develop Azure, the applications based on the components which are provided by the Azure, you can go and make use of this cloud service provider services. So you can see a lot of DevOps. They all belong to the fast category. Game development, microservice applications. Okay, so artificial intelligence, .NET. Then infrastructure as a service. Suppose the customer wants to buy the machine, virtual machine. Okay, so network, storage, all these belong to the uh, infrastructure as a service. So the customer has a application that has to deploy. To deploy, the customer needs a machine, virtual machine. Um, then the customer can go to the infrastructure as a service. So cloud carrier means carrier. You see the word carrier. The infrastructure which facilitates the uh, transfer of data. So a networking facility that provides connectivity and transport of cloud services between the consumer and the provider. So the infrastructure, networking infrastructure. Okay, so it's called cloud carrier. Cloud auditor, it's an independent entity that can assure the CP conforms to a set of standards. So the cloud service provider is providing various services to the customers. So there is an entity called cloud auditor. This entity would review the uh, services provided by the CP, cloud service provider, in terms of security, in terms of performance, in terms of privacy policies. So there are a set of rules and regulations to which these service providers, they have to follow, and they have to satisfy, they have to honor certain rules and regulations. So that would be reviewed by the cloud service auditor. So another entity exists in the cloud computing concept, that is called cloud broker. So suppose you just imagine the cloud services are very complex for the customer, and it's not easy to manage. So there comes an entity in the middle that's called cloud broker. So the cloud broker performs these three services. Service intermediation. So what happens? You can see this image. The cloud service broker and exists as an entity between the customer and the different cloud service providers. So these are different cloud service providers. So the cloud service provider consumes all the services from different cloud service providers entity and provides his or her own service interface through which the customers can avail the customized service through the service provider broker, cloud service broker. So the cloud service broker provides an interface that provides a customized service, which is based on different cloud services. So the cloud service provider invests time, effort in building application interface. It would take all the services and it would customize according to the requirement of the customers. So through this interface provided by the broker, the customer can consume the services provided by these different service providers. So the service intermediation means the value added service such as, for example, let's say the customer is consuming service of a specific cloud service provider, let's say this service provider, but through the service broker. So maybe this service broker may provide a value added service. What is value added service? The entity service broker can provide, uh, let's say, enhanced security mechanism, enhanced authentication mechanism, or enhanced authorization mechanism, or this can be considered as identity management. Okay, so user friendly interface through which the services can be consumed. So these are called value added services. So these value added services can be performed, uh, and this comes under the category of service intermediation. Service aggregation means this is a typical example of service aggregation. Multiple services go as an input into the service broker. So multiple services are aggregated, combined, and they're customized, and the customer avail the customized services which are based on multiple different services from different vendors, and this is called service aggregation, combining different services. The broker combines multiple cloud services to meet consumer needs not specifically addressed by a single CP, or to optimize performance or minimize cost. Then service arbitrage. A broker has the flexibility to choose services from multiple agencies. So here actually the broker helps a customer to choose a specific service from different customers. Okay, so this is called service arbitrage. Next, we shall discuss about the different cloud security risks and countermeasures. So next, we shall discuss about the cloud security risks and countermeasures. The Cloud Security Alliance lists the following top cloud-specific security threats together with suggested countermeasures like data breaches, data loss, account hijacking, insecure APIs, denial of service, etc. So we shall discuss one by one. The first one is abuse and nefarious use of cloud computing. So abuse and nefarious use of cloud computing. So what is this? So this threat arises because the vulnerability is appearing in these hypervisors due to some facts. Okay, here. This threat arises due to relatively weak registration system present in the cloud computing environment. In cloud computing registration process, anyone having a valid credit card can register and use the service. This facilitates anonymity due to which spammer or malicious code authors and criminals can attack the system. So weak registration system. So in the cloud service, if without any proper validation, identification, if people are allowed to register and allowed to use the service, so this can be misused by people with malicious intention. Okay, and they can do some kind of attack against the cloud computing system. So this kind of uh, weakness comes under the abuse and nefarious use of cloud computing category. How to mitigate this kind of threat? So this kind of threat can be mitigated by implementing stricter registration process and validation. So when any cloud user wants to register with the cloud service provider, okay, the registration process to be validated properly. Like the users, credit card, debit card details, address, personal details, all the informations, the user's background, all should be validated properly. And the bank cards which are used by the customers has to be monitored by credit card fraud monitoring and coordination. So it has to be monitored and it should be validated whether they are using a genuine card which belongs to them. And also, uh, uh, the doubtful candidates network traffic has to be introspected in order to find whether they are genuine user or the users with some kind of malicious intention. So basically this kind of threat arises when there is a weak registration process in the cloud computing service. So this is what given here. Countermeasure strict initial registration and validation process, enhancing the credit card or bank card fraud monitoring and coordination. Okay, so proper validation has to be done whenever the consumer uses the bank cards. So introspection of customer traffic. So these are the important mitigation steps that would mitigate against these kind of attacks. And also network blocks through monitoring public blacklists. Okay, so the blacklist informations about the possible customers or can be fetched, and these kind of customers can be blocked for any kind of services in the cloud computing. Next one is called malicious insiders. So this threat is well known to most organizations. Malicious insiders are the people who are inside the organization with some kind of malicious intention background. So malicious insiders' impact on organization is very huge. Why? Because their level of access, they exist inside the organization. They can access a lot of resources, and through this access, they can do a lot of damage, financial loss, and productivity loss. So therefore, it is critical for customers of cloud service as to what controls have been provided by cloud providers to detect and defend against the malicious. So, in a with the cloud service provider also, this kind of threat can be this kind of threat can come true. There is a possibility of this threat to really come true. Because the malicious insiders can be anywhere in any organizations. So they have a lot of access. They have the access to a lot of resources. They can do a lot of damage. So it is a must on the part of the cloud service providers to take mitigative actions, preventive measures that would protect the cloud service from malicious insiders attack, and that should be informed to the that should bring the cloud customers into confidence. So the cloud customers, they have the right to know that what kind of steps the cloud service providers uh, had taken, preventive measures they have taken in order to mitigate this kind of attack, malicious insiders attack. So these are the mitigation steps. The malicious insider threats can be mitigated by specifying human resource requirements as part of legal contracts. Okay, then conducting a comprehensive supplier assessment, providing transparency to overall information security and management practices, as well as compliance reporting and determining security breach notification process. So same thing is given here also. Enforce strict supply chain management. So that is the human resource recruitment. Okay, so when the organization cloud service provider is recruiting the human resource like IT professionals, developers, network engineers, then server engineers, server administrators. So when they recruit the human resource people, they should have a tight control. Okay, the organization should know who the organization is really recruiting. Strict supply chain management. Understand? So how they are recruited, from where they are recruited, and the organization should have complete information about the recruited people, and conduct a comprehensive supplier assessment. So, for example, if a third party, if a consultancy is recruiting the employees for an organization, cloud service provider, so the cloud service provider should assess the suppliers, the consultants, those who recruit the human resource. So, and also the organization cloud service provider has the right to specify what are the requirements from the human resource through the legal contract, and also this should bring the cloud customers into confidence. They should trust these aspects. Okay. uh, then require transparency. So the cloud service provider should have a transparent approach as far as how they implement the security in their premises, in the organizations, in their services. Okay, it should be transparent what technologies they are using, and how secured these technologies are. That should be transparent to the customers, and also how much they have compliance as far as the security practices is concerned. For example, let's say the organization has a policy that the cloud service should have a complex password for authentication. Then they should have two-factor authentication, example, uh, including biometric. But if you analyze, if you audit the cloud service provider, if you check this cloud service provider, whether they really have, whether really they have implemented the two-factor authentication or biometric authentication, or whether the password complexity they have implemented. Okay, so that is called compliance. Whether they have a policy, whether the organization follow the policy or not, that is called compliance. So as well as compliance reporting, so they should have the report whether they really follow the rules and regulations policies they have designed. And if any security breach takes place, any untoward incident takes place, like insider attack or some kind of security incidents, if really it happens, that should be documented and it should be reported. So they should have a transparent approach. They should not hide any information. So these are the different countermeasures which can be used in order to mitigate against the malicious insiders attack in the cloud computing environment. Next one is insecure interfaces and APIs. So in the cloud computing, a lot of APIs, application programming interfaces are used from, if you want to know, understand in an easy manner, uh, like library functions. Okay, a lot of functions are used in order to develop and deploy the applications, uh, deploy the systems. Okay, so how far these APIs are secure? How far the applications developed and deployed, how far they are secure? Okay, there can be some kind of security threat that can arise if these APIs have some vulnerabilities, if they have weakness. You understand? Example, buffer overflow attack. Okay, if in you would have studied that if any software developed using C language. Okay, some methods in C language they can be vulnerable to buffer overflow attack. So similarly, when you use when any APIs are used to develop applications for the cloud computing, if the API has any vulnerability, then through that the attackers can initiate the attack. Okay, so how to mitigate this attack? What countermeasures has to be taken? Let's see that. Analyzing the security model of a cloud provider interface, ensuring that strong authentication. This is very important. So you cannot memorize everything, students. Just note down the important points. Ensuring the strong authentication and access control. So authentication, like two-factor authentication, okay, and strong password, access control, which user can access, which user cannot access, and what rights the user has over the resources, access control are implemented in concert with encryption machines. So encryptions are basically is used to implement the confidentiality. And also when we are, for example, when we are developing the applications, software applications, we use third-party APIs, application programming interface from third party. For example, I am developing a Java application for some domain like human resource management system. So I want to create a PDF report. PDF report. So when I want to create a PDF report, I need some library files from a third party. So I might download the APIs from the third party and might configure in my project, and I can create PDF reports. But how far this API, which I incorporated into my project from a third party, how far these APIs are secure? Do you understand? So that that is the last point which we have to consider. understanding the dependency chain associated with the API. So from where you are exactly downloading the API, how far it is reliable. Okay, for example, now you can see students, this is a sample project. Okay, it's a HRMS application. Now in these applications, we are using, I'm using so many library files. And these library files, APIs are encapsulated inside jar file, and you can see so many jar files. So this explicitly this jar file is to create PDF reports. But this is from a third party. This is not available in core Java, so I have to get from a third party. Okay, but the thing is, I'm using this API from a third party, but how far it is reliable? So in cloud computing also, in the application development or in any software development for cloud computing environment, third party APIs would be used, right? But how far these third party APIs are secure? That's the question. That's the bottom line here. Okay, so the whenever you download or use the APIs from a third party, you have to check, you have to evaluate the dependency chain. This is very important, the last point. Okay, as far as the insecure interfaces and APIs are concerned. Another important security risk that comes to the cloud computing is from shared technology issues. So cloud service vendors deliver their services in a scalable way by sharing infrastructure. So the cloud services are scalable. It can be expanded, okay, based on the demand. Okay, it can expand according to the requirement, and this is possible by sharing the infrastructure. So the important components in the infrastructure are CPU, okay, then GPU, and memory, okay, and other resources, storage, etc. So based on these resources, the infrastructure is created, and this infrastructure is shared among different cloud users. And it is very important to have a isolation between different users to prevent each customer from interfering with other customers. So there should be a good amount of isolation. For example, a customer, cloud customer, has bought a virtual machine. In that, the customer has installed a operating system, Linux. And let's say another customer also has bought a virtual machine and loaded another operating system, let's say Windows, in another virtual machine. So both these virtual machines belonging to different users, they share the resources such as CPU, memory, storage. Okay, because from the physical machine, the virtual machines are created. Okay, so at the physical uh, machine level, physical level, these resources has been shared. So this is possible because of the virtualization concept technology. So the virtualization concept allows the compartmentalization. So division of the boundaries among different users. However, all these are technologies, virtual machines, everything are technologies. If there are any flaws or vulnerabilities, then that can be that can lead to some kind of attacks. So it is very important monitoring the system and regular vulnerability scanning to check for vulnerability and also look for configuration so that a user doesn't cross the boundary. Okay, a user doesn't try to access the other user resources. So what are the different ways to mitigate these kind of issues, countermeasures? So these are very generic in nature. Implement security best practices for installation and configuration. So while configuring the virtual machine, while deploying the operating system, so the virtualization configuration should be the best practices as to be followed. There should not be any mistake happen which would lead to some sort of vulnerabilities. And also look, always monitor the activity of each and every systems, each and every user, uh, so that if there are any unauthorized activity, okay, then that can be immediately detected and appropriate action can be taken. And also strong authentication and access control has to be implemented. Only the user with strong authentication can access his or her personal machine. And whenever the user, after the authentication, tries to access any resources, a strong access control mechanism has to be used. Access control means it determines which user can access the resource and what level of permission that user has over that resource. Access control. And also the patching or update has to be done regularly in order to alleviate the vulnerabilities, and it should be specified in the service level agreement. Okay, like the customers, they can have an agreement with the cloud service provider that specifies that the cloud service provider has to has to regularly update the systems and patch the systems and for any possible vulnerabilities. And if there are any vulnerability, immediate action has to be taken. That is called vulnerability remediation. And also, once in a while, okay, uh, it is good, better. Sorry, it's good to scan for any vulnerabilities, possible vulnerabilities, and also check the auditing, audit the systems. So these are the countermeasures against the shared technology issues. So next, possible threat risk factor that exists is data loss and leakage. So the data can be like compromising of important data cost due to deletion, alteration, uh, is a threat. It leads to loss of important data, and also it affects the reputation of the organization, trust of the customers over the cloud service provider. And if the data loss occurs, it may cause severe legal and policy compliance issues, legal issues. The customer can take severe action. So data loss or leakage have an adverse effect on the business. Okay, if the data is lost, the cloud service provider, uh, okay, while storing the data, handling the data, if any data loss occurs, it would create an adverse effect on the business. So they would lose the trust among the customers. The brand or reputation is completely lost, and the customers' moral and trust are eroded. The customers, they no more trust the cloud service provider. So why this data loss or leakage happens? This is due to insufficient authentication, authorization, audit controls, or inconsistent use of encryption and software keys. So encryption is would prevent exclusively the leakage. I mean unauthorized access. Okay. Encryption and software keys, disposal challenges, a data center reliability, and disaster recovery. So this data loss means accidentally data getting deleted, altered, etc. Leakage means the privacy of the data is compromised. Okay, so how to mitigate these issues? So students, even though there is no description for data loss or leakage for all the risk factors, I'm just explaining you. Okay, I'm giving you additional information for you to understand. So no need to memorize that, but just try to understand what is data loss or leakage. So this one you have to know what are the different countermeasures. We have to implement strong API access control. So access control has to be implemented uh, and for the application programming interface. Through the application programming interface, that is API means library methods which are used to develop the application. Strong access control has to be used so that unauthorized access over any data is prevented. Okay, only when there is no access control, people can delete or can alter the data. So if there is a strong access control and also the leakage can happen if there is no access control. So if there is a strong access control, the data loss or leakage can be prevented. Encrypt and protect integrity of data in transit. So already we know encryption, message authentication code, hashing techniques. So these techniques, there are a lot of protocols out there which can help us to securely transmit the data from one point to another. Example, SSL or TLS, transport layer security, IPsec. So VPN technology. So these technologies can be used to protect the integrity and confidentiality of the data, and also they can provide the data authentication, sender authentication, etc. So analyze the data protection at both design and runtime. While you develop the application, that time also the security mechanism, the data protection has to be analyzed. Has to be we have to see to that the data protection is available right from the application development time. And also when the application is deployed, even that time we have to check whether the data protection is there or not. And also of course for encryption, to perform the encryption we need strong key. Okay, strong key, even though the encryption is very strong, if the key strength is not good, then attackers can easily using the brute force attack, they can figure out the keys. So there should be strong key generation mechanism available. And also storage and management and destruction. Okay, so like the storage in the storage devices. Okay, like the data can be encrypted while the data is in storage, and the backup of data is very essential. So even if one copy of data is lost, no, there is option to recover from another copy. And if the data are data are encrypted, then there can be confidentiality. Privacy of the data is preserved so that unauthorized people, even the cloud service provider, without the consent of the cloud customer. They cannot access the data belonging to the cloud customers. And also, finally, when a storage resource has to be, for example, the customer no more wants to use the cloud service for storage, then in that circumstance, the customer can download all the data, and he wants to release the storage resource back to the pool in the cloud computing. So in that situation, the data that exist in the pool should be completely removed. The cloud service provider has to ensure that the data is completely removed from the resource, virtual storage resource, before it is released into the pool. Next, security risk is account or service hijacking. So the above threat occurs due to phishing, fraud, and software vulnerabilities. Attackers, they steal the credentials, username, passwords. So this is the main route through which the attackers initiate account service hijacking. So attackers can steal the credentials and gain access to critical areas of deployed cloud computing services. So using the stolen credentials, they are able to access the cloud computing service to which they are not authorized to access. Without any permission, they are accessing. So this way of unauthorized access due to stolen credentials results in compromise of the confidentiality. They can access the data, they can update the data, or destroy the data, so that the availability is affected, integrity is affected, and confidentiality is affected. So how to mitigate this kind of issues, you mean risk factor? So prohibit the sharing of account credentials. So in the cloud computing environment, don't share the credentials. And also the authentication mechanism can have a very strong authentication technologies such as two-factor authentication. And always, we have to, it is good to monitor the activities that are performed by a user account. And also there should be a strong policy that is specified in the service level agreement between the CP and the customer, cloud provider and the customer. So these kind of attacks, the prevention mechanism should be specified clearly with some kind of policies mentioned in the service level agreement. The last one is unknown risk profile. One of the best feature functionalities of cloud is that it reduces challenges and the cost spread on the installation of software. So it is easy to make to get some software available in the cloud computing environment. However, it may seem very helpful and extraordinary. It includes a few security risks beneath itself. It has its own disadvantages. Avoiding so when we avoid the security mechanism and policy compliance, how much the cloud service provider is going to follow the rules and regulations, oblige the policies. If they are not following up the implementing the policies, then it would put the customer in under risk. um, so basically, why this risk unknown profile is happening, um, log details belonging to some entity is given to other people. Okay, log details reveal sensitive data. how the specific system is functioning, how the specific, what are the activities of a user. So it is not advisable to share the log details, and also sharing the infrastructure details. Okay, the cloud computing infrastructure details with others, and also the logs which is pertain to the network intrusion detection system. We shouldn't share this information. Okay, so if at any unavoidable circumstances this kind of data, if they are shared with some unknown people, it would put us in great level of risk. So how to overcome this problem? Don't expose the data and logs to other people, unknown people. Don't reveal the infrastructure of the cloud computing environment to others. So when there is any important incident takes place, then it should be immediately escalated to the cloud service provider, and it should be informed to the customers. Okay, so these are the different risks and countermeasures I have explained in detail, and just try to understand each risk factor and how it can be prevented. What are the different countermeasures? So you should be knowing. NIST, NIST, National Institute of Science and Technology, has given some guidelines on security and privacy issues. The first one is governance. Governance means administration. So, in any organization, we have a lot of security policies, um, uh, procedures, standards for application development, for providing the services. These are related to the cloud service provider. So governance extend the organizational practices. So how the organization functions, okay, related to the policies, procedures, and standards used for the application development, software development, and whatever services they are providing, um, and also the design, implementation, testing, and monitoring of deployed services. Put in place audit mechanisms and tools to ensure organizational practice are followed throughout the system life cycle. So the governance means it's like administration, okay, ensuring that the organization follow the principles, policies, standards in each and every aspect of the application development, also in the services provided to the customers. Okay, so whether all the security policies, procedures, principles, everything, whether they are followed or not, ensuring that this is part of the governance. Okay, then next one is compliance. So the cloud service provider, they provide services in various domains. For example, medical field, they can provide some service. So when they provide medical services to the cloud customers, example, there are organizations, example HIPAA in US, United States of America. Uh, the HIPAA has laid out some rules and regulations which the entities which are involved in the medical field should follow, especially related to the privacy of the patient's data. So, in line with that, the compliance means understand the various types of laws and regulations and impose security and privacy obligations on the organization and potentially impact cloud computing initiatives, particularly those involving the data location, privacy and security controls, records management, and electronic discovery requirements. So the cloud service provider, they have to follow the laws and regulations of the country, okay, and also the organizations which has laid out some standards, rules and regulations. Okay, example, the HIPAA for the medical domain. They have to follow the rules and regulations set by the organizations such as HIPAA. So this is called compliance. Okay, this compliance can be related to privacy of the data, that the data center is located, in which country, in which place the data is stored, then what kind of security controls they have, how they manage the records, and how the electronic searching of the data is facilitated, etc. So review and assess the cloud providers offering with respect to the organizational requirements to be met, and ensure that the contract adequately meet the requirements. Ensure that the cloud providers electronic discovery capabilities and process do not compromise the privacy and security of data and applications. So the basic thing is the main summary of this content is this. The cloud service providers, as I told before, they have to follow the rules and regulations, and they have to respect the privacy and all these requirements laid out by the government as well as the organizations related to the cloud computing. Trust, actually, the summary of what is given here. First, let me read out and then give the summary. Ensure that service arrangements have sufficient means to allow visibility into the security and privacy controls and processes employed by the cloud provider, and their performance over time. Establish clear exclusive ownership rights over data. Institute risk management program that is flexible enough to adapt the constantly evolving and shifting risk landscape for the life cycle of the system. Continuous monitor of the security. So the overall summary is this: the cloud service providers, they have to be transparent, and also the security mechanism what they have placed to protect the cloud computing services, infrastructure, and the information. That has to be visible, and it has to be transparent, and it has to be monitored, efficiently implemented, and it should consider all the risk factors currently, and it should predict the future risk factors, and they should have the mechanism to mitigate any such kind of risk factors. They should have the policy and mechanism to overcome the risk factors. So this, even when they deal with the security issues efficiently, it would give some amount of trust among the customers. So the customers, they trust the cloud service provider based on how far they are good in dealing with the security matters. If the cloud service provider is able to efficiently handle the security issues, then the amount of trust the cloud customer has over the cloud service provider would be more. Similarly, if the cloud service provider fails in dealing with the security issues, then the amount of trust the customer has over the cloud service provider would drastically goes down. And the trust is very important for the in the business point of view. So architecture means the infrastructure of the cloud computing environment. So understand the underlying technologies that the cloud provider uses to provide provision services, including the implications that the technical control involved have on the security and privacy of the system over the full system lifecycle and across the system. So the the customers, they have to understand the and also the organization which provide the service, cloud service, they should have a clear understanding about their infrastructure in place and how security mechanisms are implemented in order to protect the infrastructure. And this security mechanism has to be protecting the complete life cycle of the application development, deployment, and maintenance. Okay, so this has to be clearly updated to the customers in order to establish the trust. um, Identity and access management is related to the authentication and authorization. So they should have a efficient, the summary of what is given here is they should have a very efficient authentication and authorization mechanism. So authentication mechanism identify the person, and access management controls the access resources. Uh, okay. Then software isolation, understand virtualization and other logical isolation techniques that the cloud provider employs in multi-tenant software architecture. So there are many the resources are shared among multiple tenants or multiple customers, users, and there should be a strong isolation of one user from between different users should be in place. This is the very important aspect that is required from the cloud computing. Since the different users share the resources, common resources, there should be a isolation, strong isolation that protects each user from other users who all share the same cloud computing infrastructure. So data protection, evaluate the suitability of the cloud provider's data management solution for the organization, data concern, and the ability to control access to data, to secure data while at rest. So this data protection means there should be access control. Already we discussed at many places, but under the banner data protection, please understand data protection can be implemented using access control, securing the data at rest and transmit. I mean, when the data is stored in a device, the data has to be protected. Like we can use the encryption technique. While the data is transmitted from one point to another, it can be protected. There can be integrity check, there can be confidentiality. Okay, there are a lot of protocols which involves the encryption and the hashing, message authentication techniques. Symmetric, asymmetric keys are used. So this technique, combination of these techniques can be used to protect the data while at rest as well as during the transit. Take into consideration the risk of collating organizational data with those of other organizations whose threat profiles are high or whose data collectively represents significant concentrated value. Fully understand and weigh risk involved in cryptographic key management with facilities which facilitates available in the cloud environment and the process established by the cloud provider. So the summary of this is while we share the data among different organizations, we have to take utmost care. And then second, the third point is which is related to the first point here. Uh, uh, Related with the encryption, the key management aspect is also very important as far as the data protection is concerned. When cryptographic encryption, decryption techniques are used, of course, it needs the key, and the key management has to be efficiently implemented. The privacy of the keys and also unauthorized access of keys should be prevented. The privacy of the key has to be implemented, and the unauthorized access of the key by unauthorized person should not be allowed. Then the next point is availability. Understand the contract provisions and procedures for availability, data backup and recovery, and disaster recovery, and ensure that they meet the organization's continuity and contingency planning requirements. Ensure that during an intermediate or prolonged disruption or a serious disaster, critical operations can be immediately resumed and that all the operations can be eventually reinstituted in a timely. So availability is very, very important for any cloud service provider. The service has to be available like 24 hours a day, 7 days a week, 365 days a year. So all the time the service has to be available. If the service availability is disrupted, then it would affect the business aspect of the organization. So how we can ensure the availability by data backup? Okay, data backup should be there, and the data recovery mechanism. Okay, in case any damage to the devices, storage devices, there should be recovery mechanism should be there. So in case of any disaster incidents happen, um, uh, the organization should be resilient to overcome the disaster recovery like earthquake, flooding, fire, etc. And the company organization should have the continuity and contingency planning. Okay. So in case of any disruption or serious disaster, the organization, if they have a proper backup recovery plan, they can immediately come back to service. They can recover, resume immediately. This is very important for the business from the business point of view. The incident response. So understand the contract provisions and procedures for incident response and ensure that they meet the requirements of the organization. Ensure that the cloud provider has a transparent response process in place and sufficient mechanism to share the information during and after the incident. Ensure that the organization can respond to incident in a coordinated fashion with the cloud provider in accordance with their respective roles and responsibilities for the. So so first of all, every organization, small or big, they have this incident response mechanism, procedures, how to deal with the incidents. Example, let's say the data center is affected by a fire or flood or cyber attack, virus attack, worm attack, denial of service attack. So these are the examples for incidents. So when any incident occurs, how the organization responds, how the organization has to respond. So the organization, especially the cloud service providers, they should have a procedure, plan. So when any incident occurs, how the organization can respond. Example, if the fire occurs and if the devices are damaged, what should be done? How to deal with this? Okay. So the organization should have a clear-cut procedure and plans, and it should be understood clearly by the stakeholders, the people who are involved in the organization. Also, next one is whenever any incident takes place, it should not be it should not be hidden. It should not be hidden. It should be the organization should be transparent and they have to clearly inform the important stakeholders. So okay, if any incidents happen, so and so incident has happened and how the organization responded, everything should be documented. There should be a transparent approach. Okay, and the organization should not try to suppress the facts information. Okay, then To overcome the incident, to respond to the incident, there should be a coordination among various departments, various people involved in the cloud service, in the cloud computing service. Okay, so this is another important thing. And how the organizations, how the different departments they are going to coordinate, everything should be specified in the plan and procedures. Next topic, what we are going to discuss is data protection in the cloud. The threat of data compromise increase in the cloud. Database environments used in cloud computing can vary significantly. So there are two cloud models available. One is called multi-instance model and another one is called multi-tenant model. I will show you, I will explain. First, let me read out the content. Multi-instance model means provides a unique DBMS running on a virtual machine instance for each cloud subscriber. For example, the cloud, let us assume many customers, they want to have a DBMS service. They want to consume the DBMS service, database management service, like MySQL or Oracle like that. So in the multi-instance model, okay, for each and every customer, a unique DBMS running on a virtual machine instance is given. This gives us, the customer complete control over the roles. In database there are roles, users. Okay, so you can using this model, the subscriber, the person who gets the service, has a control over the a complete control over the roles, configuration of roles, user authorization, and all the administrative tasks related to the database management system security. Example, you can see this is a multi-instance model. So these are the different sets of people. They want to have get a cloud service related to the database management, relational database management system, or non-relational database management system. So this is one virtual machine. So in this one virtual machine, there is a database instance that is exclusively allocated to this subscribers. And the second instance, which is running in a separate virtual machine, is allocated to another set of subscribers, and so on. Okay, and another the variant of the multi-instance model is multi-tenant model. You can see there is a single virtual machine. In the single virtual machine, there is only one instance of database running, and basically there is an interface. Okay, that interface is allocated for each user separately. So this set of user would connect to the database through the interface. So logically, the physical machines are divided. Okay, this physical machine, even this virtual machine, excuse me, even this virtual machine instance is logically shared among multiple users. Okay, you see the difference here. There is more security. However, here, all the set of users, they share the same instance. But however, they have a separate interface through which they connect with the database engine. And each person's data, each subscriber data is identified in the database engine using a tag which is related to the subscriber. Okay, subscriber one, when he or she puts the data in the cloud database engine, that data would be associated with a tag related to the subscriber one. Similarly, the data related to the subscriber two would be tagged with the subscriber two identity, and so on. Okay, so this is the basic difference between multi-instance and multi-tenant. So multi-tenant model provides predefined environment for the cloud subscriber that is shared with other tenants. So single instance cloud computing database environment is shared among multiple tenants. through tagging technology with a subscriber identifier. So each subscriber has an identity that would be tagged with the data that is stored so that it is easy to differentiate the data. Tagging gives the appearance of exclusive use of the instance but relies on the cloud provider to establish and maintain a sound, secure database environment. However, here there is a lot of responsibility on the part of the cloud service provider to secure the data. One uses data from other users. Data protection in the cloud. So data must be secured while it is stored in some device as well as while it is transmitted across the network. It has to be secured, and also the access. Okay, it should be allowed. The data should be allowed to access by the authorized person, and it should not be allowed to access by unauthorized people. So, in order to protect the data while at transit as well as while in storage, the encryption technique is very important. It can be used to implement the confidentiality. There are many ways by which we can protect the data stored in the cloud. In one instance, for example, we can encrypt the data and then we can store the encrypted data in the cloud database system. Okay, or we can encrypt the entire database system. For data at rest, the ideal security measure is for the client to encrypt the database and only store encrypted data in the cloud. And the key should not be shared with the cloud service provider. Another approach is encrypt the entire database. This is also another option. And in this scenario also, the encryption or decryption keys should not be shared with the service provider. In this scenario, the user has little ability to access individual data items based on searches or indexing on key parameters. The user would have to download the entire tables from the database, decrypt the tables, and work with the results. To provide more flexibility, it must be possible to work with the database in its encrypted form. So, in this scenario, if the entire database is encrypted, the user has to download the entire encrypted database, then he has to decrypt, and then he can like and work with the results. Okay, you can pass some query and retrieve the results. So this is a scenario which this image shows clearly how the encryption technique works in the database system. So these are the different stakeholders: data owner, organization that produces data to be made available for controlled release. So they are some organization, some entity which produce the data and they are the owner of the data. User, you can see the user that presents queries to the system. So the user wants to search some information in the database system, send the query and retrieve the result from the database system. Uh, the client is a framework here, front end that transforms user query into queries on the encrypted data stored on the server. So the data in the database system uh, is in the form of encrypted. It is encrypted and stored in the encrypted form. So whenever the user send the query, that has to be processed, transformed into queries, okay, so such that it is understandable to the database system, which is in the encrypted form. So now the encrypted result comes back to the client framework. It would process the query using the metadata. The data about the data is called metadata, like what key has to be used to decrypt or understand initialization vector. Such kind of details are in the metadata. And encrypt or decrypt algorithm like DES, AES algorithms, okay, they are used by the client framework. So please understand some data is stored in this server in the encrypted form. So now the user is sending the query. So the query is transformed, okay, it is processed, it is transformed into a certain specific format so that this query is understandable to the encrypted database engine. It sends a response back, encrypted result. That would be processed by the query processor. To process, it has to use the decryption algorithm, and also the key information which are stored in the metadata. And of course, the data owner here you can see produces the data, so has the database, put the data into the database, and it would be stored as in the encrypted format. And to do the encryption, what kind of metadata, what kind of keys are used, that would be stored in the metadata repository, and that would be passed on to the client framework. So now the point, this server is located in the cloud service cloud environment. So let us assume this is provided by a third party. If the third party try to access the encrypted data, the third party cannot access the plain text, and this data is of no use to the cloud service provider. And if the keys are very strong, and the encryption and encryption techniques are very strong, very efficient, then it is not possible for the highly impossible for the someone to break into the server database engine to access the plain text which belongs to some other person, example data owner. So these are the terminologies related to the relational database system. Relation, a flat table, which is the basic building block. Tuple means rows. Okay, so relation consists of rows and columns. Attributes means columns. Primary key is defined to be the portion of a row used to uniquely identify a row in a table. Example, employee number, student number. Okay, so it is used to identify the other columns. It can be a single column made up of single or a combination of one or more columns. So these are the different topics in the cloud computing related to the cloud security. So with this, I conclude this lecture. Thank you very much.